How is the energy of the universe conserved during the combustion of gasoline? Gasoline is a hydrocarbon. It has a combination of carbon and it's a molecule that has a carbon and hydrogen in it. Hydrocarbon combusts or burns. It's going to combine or it's going to react with oxygen and produce carbon dioxide and water. At least that's what happens in a complete combustion. However, in reality, cars are not nearly as efficient, so you're going to get other pollutants as well. Now, this is an exothermic reaction. It's going to produce heat. And so if we put this into like an energy diagram, let's say, the reactants, well, gasoline specifically, the bonds in that chemical are relatively weak. So it has a lot of potential energy. And when they break, when these bonds break to form the bonds that make up the products, those bonds that make up the products are much stronger bonds. So when they form, it's highly exothermic. So the products are down here, right? So this energy difference here is the change in potential energy. What do you think? Well, it's pretty clear the potential energy decreased from the potential energy stored in the gasoline to the potential energy stored in the products. So where did that energy go? Potential energy just doesn't disappear, gets destroyed. No, that gets converted to kinetic energy. This random kinetic energy that is what we call thermal energy. That's why your cars get really hot, engines do. Now that kinetic energy is in turn going to be used to do work in a piston or on a piston in a cylinder. So your engine has cylinders and there's a piston in there, and then this reaction happens in here and does work on this piston which moves the car and so on. Now I'm not sure if this problem is looking for all that detail. I think the problem just wants you to know that energy is conserved, because although you do have less potential energy, it's simply not being destroyed, rather getting converted to another form of energy.